Hello everybody and welcome to this week's lessons for year 8 and today we're going to have a look at some algorithms. You'll see on screen here we've got some flowchart symbols and that's because when we're designing a program, we're designing what we want a program to do and we start thinking about its algorithms. We need to think about what order things happen in. And so one way that we can do this is with a flowchart that helps us visualize what things are going to have to happen in what order. So here you've got some symbols that you use. So we've got this oval symbol, this curved edges here on the start and end symbols. So we'd use those ovals at the start of our program and at the end of our program. And then you've got processes. So processes are things that the computer does as part of the algorithm. So it just does them. There's an input, something goes in, it does that process, something comes out. You can see the information is represented by arrows. So the information goes into the process, the computer does something to that information, and then it comes out of the process, and you see the data coming out with the arrow here. If you've got a decision, so a decision is where a computer might make a decision based on the data it gets. So for example, if we were talking about odd or even numbers, so that might have a number comes in here, and if that number is odd, then it's going to come out on this side, and if that number is even, it's going to come out on this side. So it's got a decision to make, and depending on the information that comes in will depend on the information it sends out. So for example, if we put the number 6 in here, then it would carry on, the data would carry on this way. If we put a different number in, if we put an odd number in, if we put 3 in, it would go into here, but it would actually come out this side, and that would change the path of the algorithm and change how that algorithm worked. Now, I want to sort of share a complete algorithm with you. So here's one that we've got, and if you look through it, we can figure out what this algorithm does if we follow it through. So we've got the oval symbol at the start, which is for our start, and then we throw dice. So the first thing is a process, and we throw the dice. Then we move on with that information and we move our counter the number of places shown on that dice, and we follow it through until we get to a decision. So the decision says landed on a snake head, so we've got to decide, did we land on a snake's head? Yes or no? Now at this point you might be thinking, hang on, I know what this algorithm does. This is an algorithm for a game of snakes and ladders, and every time you play snakes and ladders you actually follow this algorithm as a person, but this is set out so a computer could understand it. So it says, right, did you land on the snake's head? So let's say we didn't. So then it would check, did you land on the bottom of a ladder? Let's say we didn't. Have you reached the last block of the game? Well, probably not, we've just started. So we'd say no, and we'd follow the data all the way back around to this process here that says give the dice to the next player. And we go back to the start and they carry on their go, saying throw the dice, move the counter that number of spaces, have it landed on a snake head. If they did, and they'd say yes, it would slide down the tail of the snake, they'd give the dice to the next player and round again. Or if they land on the bottom of a ladder, they move up the ladder, they give the dice to the next player, and they start again. So it's a full algorithm until you get to the very end. You reach the last block of the game, yes, you are the winner, and then we've got our end shape there. Right, so that's the full algorithm. Now actually what I want to do is I want to break this down. I want to take this into smaller bits to break down. So I want to look at literally just this process today. I want to break down and look at just throwing the dice and thinking a little bit about the number of spaces we're going to move as well. So this is the algorithm that I'm really interested in, this process here. So we're going to look at creating that today. So let's get a website that we're going to use to write some of our Python. I know I use idle at school, but I know you're not going to necessarily have that. So we're going to use something different. We're going to use a web-based solution for us. So we're going to use a website. So here we've got a website called reptal.it or replit with a dot in it, and this is going to allow us to do some Python online. So if you're following along now, pause the video for a second, open up a browser, go to repl.it. You'll need to choose that you're doing a new reptal, so it's a reptal plus, make a new one, and you're doing Python, and it'll load up onto this screen here. So on the left hand side here is where we're going to write our code, and on the right hand side here is where our output's going to be. So a little bit like idle in that respect. So let's start thinking about a algorithm that's going to roll a dice and count out the number of steps we need to take for our dice. So first thing I want to do is I want to be able to roll a dice. So we're going to have to be able to get the computer to choose randomly from 1 to 6. And to do that, we need to import the rules of randomness into Python, because Python, when it first loads, doesn't know this, so we need to import them. So we're going to put import, and I'm going to put import, yeah, that's right. And I want to import the random module, and we just write random. Awesome. So there's my first line, done. Happy days. Right, let's imagine for the moment we're going to only have 1 dice. We'll make it 2 later on, but I think we'll start with 1 dice. So I'm going to make a variable. So remember, a variable is just somewhere I can store a value, and this variable is going to be my first dice. So I'm going to call it dice1, and I'm going to store my variable as dice1. So that's the name of my variable. Then I've got my assignment operator, and I use this to assign the value to dice1. And then here's where my random module is going to come in. So I'm going to say I want you to pick a random.randint. Now randint is actually 2 words joined together. That's called a portmanteau. That's the proper word for that. But the 2 words are the word random and the word integer. Now, you might know those words individually, you might not, but basically it's going to pick a random whole number from a range of numbers that I give it. So the random integer I want it to pick between is from 1, because that's the lowest score I can get on the mouse. And then I put a comma in and I say 6, because that's the highest score I can get on a dice, not a mouse. Right, so it's going to pick 1 to 6. Okay, let's just see if I can make this work. So I'm just going to print what dice1 is. So if I run through this algorithm, it's going to import the random module. It's going to randomly select a random integer between 1 and 6 and store that as dice1, and then I want it to print dice1. So I'm going to run it and see if it works. Fingers crossed. Okay, so it's just printed the number 5, which is kind of what I expected, if I'm honest. It's just printed the number 5, so that's fine. Let's get a second dice involved then. Let's do another dice. So I'm going to go the same sort of thing, but I'm going to make another variable, but this time call it dice2. And dice2 equals random.randint. So same command again, same range again, because it's a dice, 1 to 6. And then I'm going to get it to print dice2. Oh, now I've made a little error there, and it's trying to correct me because I didn't put a capital D the second time I wrote dice2, and it's got to be exactly the same. So it's suggesting, do I want a capital D? Yes, I do. Okay, let's run that. We should get 2 values this time, so I've got 2 and 4. They're different, which is good. I wouldn't want them to be the same unless it was randomly the same. Let's just try it a few times, make sure I'm getting random numbers each time. 4 and 1, that's good. 6 and 5. 3 and 5. 1 and 1. Okay, so they can be the same, that's good. Okay. Let's see if I can zoom this in for you guys so you can see it nice and big. Awesome. So, we can run this. Great. So, we've got 2 dice that roll. Now we could just leave it at that, but it would be even better for me if the computer did the adding up for me. So I'm going to try and get it so it adds those 2 values together and just tells me what the total is, and that's how many spaces I've got to move. So let's do that. Let's make a new variable called total. So this is our total, and our total is the value of dice1 plus the value of dice2. Ooh, don't need a space there. Okay, so I've made this new variable and it is the total of dice 1 and 2. It's adding them together. Brilliant. And then I want to tell the player what their total is. So we're going to print and we're going to say you rolled A, and then we want to add in that total, don't we? So we're going to put a new set of speech marks. I'm going to say plus total. Cool. And then I'm going to stop there and going to test it first. So I'm going to test it and see if that works. So it should, I'm hoping it's going to print you rolled A and then give me a number, and that number will be whatever the total's been stored as. Right, okay, now it's giving me an error. So it's saying here in this last line, I can't concatenate, that means join, a string. I can only join a string, not an integer. So this is an integer. These are numbers, and it's saying I can't put the numbers into this print. So you need to make it into a string for me. So we can do that. If I go string total, what that will do is it will turn whatever the value of total is into a string. So if we try that now, let's give that a go. Oh, no, what went wrong? Something's gone wrong here, guys. Oh, I know. I know. So I've got to tell it that I'm going to reassign total as a string. So we're going to resave total, but this time instead of it being the integer, it's going to be saving as the string. Let's try that. Oh yeah, there we go. Okay, so we rolled a 3 and a 3, and it says you rolled a 6. Now there's one thing bugging me with this. I haven't got a full stop at the end, and English is always important. So I'm going to come in here and I'm going to add in a bit of grammar. So I'm going to put plus new speech marks, full stop, new speech marks. Okay, so hopefully now I've got a full stop on the end. You roll a 9. Fantastic. Right, now we could, if we wanted to, we could leave those dice in so they can see their individual dice rolls. We could put a hash in front of these. Now what hash does in Python is it actually means that the computer won't read that bit of code. So if I put a hash in front of those, it will no longer print dice 1 and dice 2. And I should just get the last line. You rolled a 2. I must have rolled a 1 and a 1. And again. And again. Now it's up to you guys how you want to do that. Sometimes it's nice to be able to see what the individual dice were, what the variables were, so you can check that it's working. But once you're happy it's working, you can sort of hide all that messy stuff and just have the output of you rolled a 7. So guys, that is the algorithm for that. If you've managed to do that, I would love for you to take a picture and show me it working, submit it onto the VLE, that'd be great. Or, you know, if you've had any problems, put them in the comments. If you would have enjoyed this video, it's been really good and it's helped you out, please give it a like and let me know in the comments what else you'd like me to do. And look after yourselves, guys, and I hope to see you again soon. Bye, everybody.